So I actually found the problem, and here it is. So the setting is basically you have a square inside a square, and there's a circle here. Now this circle should touch this, so it's actually not drawn very nicely here. Just correct. There we go. And this square has an area of 100. And this rectangle right here has an area of 24. And now the question is, what's the area of this circle? And now, this is again what I mean. Like, this problem, like, some people will appreciate this problem, some people won't appreciate this problem. I, for example, do appreciate this problem because I think it's just, it makes you think, you know, it makes you stand there and think, okay, well, how am I going to approach this? Well, the way that we're going to approach this is that we know that we can do one thing. So a square in a square is defined for having all four sides the same. And we know that the area of a square is basically just the side times itself. So a squared, let me call it a. We also know that the square has four sides that are exactly the same. So we can actually just take this area, so we can actually just take the square root of a, which is just the same as the square root of, excuse me, a is actually the square root of, a is the side, and if we don't know the side but we know the area, we can just take the square root of a squared exactly, and that gives us 10. So we have 10 for a is 10. And so we're gonna now do the next thing. And another thing that's nice, like when I look at this, I can say, okay, 24 is here, but 24, because this is the same everywhere. So this must also be here, and must also be here, and must also be this. So these must all be 24. And so I can say that the total, that the sum of the whole thing, the area of the whole thing, is 100 plus 4 times 24, which is just 196. Now if we take this whole side and name it b, same thing as last time. We go 196. Square root of 196 is b, and that is equal to, I think it's 14. Just pull out my calculator. Of course, you could also do this in your head, but that is correct. So 14. So we now know that one side is 14, and what can we do with this information? How does this even help us? Well, what do we actually need to find out? We need to find out this length right here. So let me just actually do it like this. This is going to be C. And this length is going to be D. To actually then find out what the area of the circle is. And so let me speed things up a little bit. So we know that C squared plus D squared is equal to A squared. That's just the Pythagorean Pythagoras' theorem. Let's just put it this way. That's his theorem, that these two sides squared equals that side squared. And of course, if you take the square root, then it's just A is equal to the square root of C squared plus D squared. So, and we know that A is 10. So we can say that 10 to the power of 2 is equal to C squared plus D squared. Okay, and now we can also say that, because again, nice thing about math, looking at this, C is here, but we said that all of these are the same. So actually C is not only here, but C can also be flipped up to here, and C can also be seen right here. And we know that the length of one side, we know that C plus d is equal to 14, right? So, what do we do? Well, 10 squared is equal to c squared plus d squared. C plus d is equal to 14. What can we do? We can substitute for the different numbers. So, let's for example take d. We can write d equals 14 minus c. Is that right? I think that's correct. And now, we're just going to have to put this expression into this right here. So we have 10 squared is c squared plus 14 minus c squared. Relatable, right? I think. Now, if we now just, go further in this, we can actually see that we first need to multiply this out, so let me actually do that. 6 minus c squared, what is the rule? The rule is that we go minus 2 times 28c plus c squared. So in the end we have 10 squared is equal to 2c squared plus, minus 28c plus 196. Subtracting 100, we have 0 equals 2c squared minus 28c plus 96. This is the calculation that I now have done. And now from this, we're actually going to use the x12 is equal to, you all have learned this, minus b plus minus square root b squared minus 4ac divided by 2a. That's it, right? That's it. And so, plugging our numbers in, we can see that a is 2, b is equal to minus 28, and c is equal to 96. Okay, plug that in. Minus 28 is just plus 28. 28 plus minus square root of 28 squared, which is quite a large number. Let's write 28 squared minus 4 times 96 times 2 divided by 2a, which is just 2 times 2, which is 4. And when we calculate this out, we get 28 plus, so x1 is going to be 28 plus square root of 28 squared minus 4 times 96 times 2 divided by times 2, and that's going to be x1. And it's going to be x2 is going to be right here. X2 is going to be 28 minus square root of 28 squared minus 4 times 96 times 2 divided by 4. Plug it into the calculator. 28 minus square root of 28 squared minus 4 times 96 times 2. It's going to be 24, 6. And there we have it, lads. We now, from only knowing the area of this and the area of this, now we have successfully calculated what these two lengths are. We can now put d equal to 8, d equal to 8, and c equal to 6. And let's actually check that, whether or not that is actually correct. So, how can we check that? Is that correct? Let's check that. 6 squared plus 8 squared should be 10 squared. Is that right? Let's see. 36 plus 64 is 100. So this is actually correct. Alrighty, guys. Now the question is, how are we going to calculate this circle right here? And that's actually not too difficult, but you have to have some mathematical knowledge. I must admit, I did go on the internet for this, just for one thing that I did not know. But once I actually, I'm terrible at drawing. Once I actually found that, it actually kind of made sense. So one thing you guys need to know for this right here is that the middle point of the circle is right in the middle of these angles. Now that might seem obvious, but in maths, it's usually, God, my drawing is terrible. It's sometimes not as obvious as this. So you always have half of the angle is where the circle center is. So we now know that this side is 10, this side is 8, and this side is 6. And we also have a right angle right here, right? That's correct. Alright, So what do we do now? Well, we have three angles. We have, let's just call this angle alpha, this beta, and we need no name for this one because it's just a right angle right there. Yeah, and now calculating the angles, what can we do? How can we calculate the corresponding angle? Also, another invention, you could also say, but I think it's something very nice, something very useful. So we can now say, we can use sine, cosine, or the tangent, whatever we want to. So we can just say that the sine of an angle is divided by the hypotenuse is the opposite side divided by the hypotenuse. So we just have 6, let me just say opposite side, so that is equal to 6 divided by 10, and that is just 6 over 10, so that's just 0.6. And if we want to get the angle, we just go arctan of 0.6, which is just equal to... Hey guys, my camera just died there, so sorry about that. Anyways, back to the action. So, yeah. So, kind of thrown off guard here. I'm not gonna lie, but anyways, let's get back to the thing. So, we know that arctan of 0.6 is just, I plug that into the calculator, and we have beta is just because we know this is a right angle, and we know that the sum of all angles in a triangle is 180 degrees. So we can just subtract 90 from that, leaves us with 90 minus alpha is equal to 53.13. Good. Now the question is, how are we going to advance? Well, we now need the radius. So the radius, I'm actually going to draw this in color so you guys can actually see this a little bit better. So we now need the radius. So this length right here. How do we do that? Well, let's approach it in a way. I'm going to use a different color, actually, blue right here. So we need the radius, and for the radius, let's actually draw out this bottom triangle right here, just this part right here, with this being the CS center and this being RS radius. We know that this is 8, and we know that the center is in half the angle, this angle divided by 2. So we know that this is alpha divided by 2. Good. Nice. So now, again, we just do some simple math and figure out what these other angles are. Now, we have a right angle right here, so actually it's not even that difficult. We again have a right angled triangle, which means we just need some simple calculations to figure out what R is. Well, how do we do that? We have one side is 8, one side is R. The problem is that it's not this length that is 8 right here, but it's the whole length. So let's think about this. How can we actually calculate this now with only knowing this part of the triangle and that there's a right angle right here? What do you think? Oh yeah, I got it, of course. Simple. So we know that this angle is 19 divided by 2 because it's just from this corner to the center. So we have 45 degrees right here. So that leaves us with a simple application of the sine theorem, which states that the sine of an angle to its opposite side, so sine of alpha to A is equal to the sine of beta to B. So applying this right here, we just have to calculate one length, which let's just calculate which is this length right here, let's just call this E. So we have E to sine of E over the sine of 45 degrees is equal to what? Well, we can actually choose. We don't even need to worry about that too much. We know that this is alpha half, and we actually, because we know that this is 8, so we should take this angle right here, which is going to be probably greater than 90 degrees. So we're going to have 180, which is just the sum of all angles minus 45 minus alpha divided by 2, which is equal to, let's see, minus this divided by 2, which is just 116.5. 0.565 degrees, which is the same as 8 over the sine of 116.565 degrees. Now we just multiply this by the sine of the 116, and we get, sorry about that, sine of 45, of course, and we get E is equal to 8 times the sine of 45 divided by sine of 116.56, and so on. Plug this into the calculator, and we get 8 times the sine of 45 divided by sine of the answer, which is just 6.32. Where is it at? It's right here. Okay. So we know that E is 6.32, and from this point, I don't think it's too difficult. We know this angle, we know this length. Again, we can just use the sine again. So we can just say again, sine of alpha divided by 2 is opposite side divided by hypotenuse, and in this case it's going to be, the hypotenuse is going to be E, and the opposite side is going to be R. So let's just plug that in actually. So we have opposite side is R divided by E, so we have R is equal to E times sine of alpha divided by 2. Great. Should be right there. And we just have times the sine of alpha divided by 2, that's this angle right here, times the sine. Shit. Wrong. Plugging in there. 2! There we go. Right, this is 2, guys. And that's that simple. And now if we need the area, easy peasy. R squared times pi. 4 pi. That's the answer right there. So, going from this to this is why I think that math is beautiful. Because all of this, you know, like, you just have to think a little bit, but then it's a nice problem which you can solve all by yourself just by looking at it. So we actually, what we did, okay, there's the area there, okay, we can do this, we figured out, okay, this has to be 8, this has to be 6. Then we drew out the whole triangle, we did some simple math right there, basically just, then we said, okay, we have one side here is 8, angle there, and we came to the conclusion that it is equal to 4 pi. Guys, I want to thank you very much for watching. A little bit of a nice, you know, of a nice tasty treat, I would say. No, thank you very much for watching. Do some math, guys, and also drive. You know, driving is also very nice, but yeah, just go ahead and do some math. These kinds of problems, you can find them on YouTube, Google, anywhere. I actually took this from some guy on YouTube that I saw. I actually did this myself. And yeah, thank you very much, and have a good day, guys.